Rust and its prevention. As discussed earlier, corrosion is the deterioration of a substance due to chemical reactions with the environment. While ceramics and polymers can corrode, this topic will only cover metal corrosion. Corrosion of iron is called rust. Iron easily corrodes in oxygen and water. It reacts with oxygen in the presence of water to form rust, which is mostly made up of two iron oxides. Iron plus oxygen and water yields iron oxides and water. So we have iron 2 oxide and also iron 3 oxide. Rust is a red, orange, brown, flaky material that forms on the surface of iron. It reduces the overall strength of the iron and is easily scraped off, further weakening the iron. Rust also supports the growth of bacteria that can cause tetanus if the sharp rust cuts a person and enters the bloodstream. The rust reaction is not a very fast one, but it can be sped up by increased moisture in the environment, acids such as low pH liquids in contact with iron or acid rain, and salt such as ships sailing in salt water. There are many ways to reduce the corrosion of metals. Each must be evaluated for practicality, cost, and effectiveness when planning a corrosion reduction program. Some samples of this are corrosion-resistant metals, barrier coatings, and environmental control. Materials such as aluminum, copper, and stainless steel, which is an alloy consisting mostly of iron, chromium, and nickel, have a high resistance to corrosion. Aluminum, copper, and the chromium in stainless steel combine with oxygen in the air to form oxides on their surfaces. The oxides on the surface of these metals forms a thin, hard barrier between the air and the rest of the metal, protecting it from further corrosion. Another way to prevent metals from corrosion is to coat them with a material that prevents the interaction of the environment, water and oxygen, with the protected metal. Proper coatings are harder to oxidize than the protected metal. The problem is that the coatings, such as special paints, typically consist of toxic chemicals and they can wear off over time, exposing the metal to corrosion. Galvanic steel uses a zinc barrier coating that is applied by dipping the steel in molten zinc. This provides a physical barrier between the environment and the steel, protecting it from corrosion. When possible, reduce the effect of the environment on the metal by reducing exposure to rain and seawater, treating water to reduce hardness and acidity, and reducing exposure to chemicals such as chlorine and oxygen that would react with the material. For water pipes, the pipes can't reduce their exposure to the water as that's the purpose of the pipes. But the chemistry of the water can be controlled to reduce corrosion. Oil and gas pipes exist in a harmful environment whether they are buried or exposed to the air. Another protection method is required: cathodic protection.